Alright everybody, there's one last thing I wanted to talk about here on your note sheet that we didn't get to yesterday. Take a look at the back side of your note sheet and take a look at this weird looking statement over here, which really doesn't have a whole lot of context right now. So with this question, I wanted you guys to sketch a graph of the region that the sprinkler can cover. Well, what sprinkler? Well, how about this one? So take a look at this. Okay, so what I would like you guys to do is on your polar graph that's on your note sheet here, I'd like you to try and sketch out the area, the possible area that the sprinkler can cover. This becomes a pretty tricky question if we don't have a little bit more context in here. So suppose we provide a little bit more of an assistance. What if that sprinkler we're looking at covered this amount of ground? So suppose that sprinkler covers the given direction right there, goes from negative 30 degrees to 210 degrees, and then it has a radius that can cover of a good 20, let's just call it 20 feet. How would that look on that graph of ours? Well, if we had to cover the given direction there, going from negative 30 degrees to 210 degrees, it would kind of picture it looking something like this. And when we combine that with the fact that they want us to cover a radius, say, of maybe 20 feet, pretty simply we can probably just even sketch this outer ring here to just be 20 feet. So now the question becomes here, if we just look right down here, is find the area of that region. How do we go about doing that? Well, if we wanted to find the area of this region here, realize that you're looking at a fraction of the circle. Well, how much of a fraction? We figure that out based on the information we have here. If we're going from 210 degrees to negative 30 degrees. Yeah, going from end to end here covers a span of about 240 degrees here. And one way of looking at this is thinking that it's 2/3 of the area of the circle. So if it's 2/3 the area of the circle, we can just apply our area formula with our radius being 20 and then just take 2/3 of it. Right, so not too bad of a problem to solve there. And we might see a similar problem like that down the road, trying to find area inside that circle. Just realize you're just looking at a fraction of the circle. Let's take a look at another problem. This is from your activity from today. Alright, so at a certain point at the very bottom of your worksheet, you'll notice that you get to ask this question. Find the distance between the 2 points with the given polar coordinates. I'd like to focus just on question number 10, and I'll have you guys take a look at question number 11 on your own and try that. So if I focus on question number 10, I can do this problem or see this problem a little bit easier if we had a polar graph to assist us here. So let's try and think of a polar graph while we're working on these problems. First thing we'll do with this polar graph is let's just plot the points. Let's plot P1. And now let's plot P2 at 2, 130 degrees. Now let's take a closer look at this too while we're at it. Alright, so just to reiterate the objective here, what they want us to try and find is find the distance between these 2 points. And now in order to figure out that distance between those 2 points, let's, can you see it? And you see what we're going to be able to do here with this? You guessed it, we're making a triangle in there. Now, how do you suppose we're going to go about figuring out how many degrees are in that angle right there? Give you a hint, we did it earlier in the year. Actually, we did it just in the last test, didn't we? Why don't we just subtract the two angles that they gave us? So we have 90 degrees, and we're going to 130 degrees. So wouldn't that make this angle in here 40 degrees? So now if that's 40 degrees, let's fill in a couple of other pieces of information that we know. Don't we also know that this length right here was 6? We know that this length right here was 2. And so now notice with our side angle side here, do you think it's now possible to figure out how long that is right there? And so how are we going to do it? That's right, law of cosines. Law of cosines will be able to figure out the distance between those 2 points. Okay? So, try and finish up that problem there, and you can also do the same thing with number 11.